using CircuitPython for device-to-device communication over Bluetooth. Hello makers, it's Prof G, and we're about to experience a bountiful Bluetooth bonanza as we learn to connect two CircuitPlayground Bluefruit devices wirelessly over Bluetooth. One device will act as a remote control, and the other will respond to signals sent to the remote. Now, while this lesson requires two devices, connecting devices this way can be super useful for building a custom remote control. For example, here's a prototype video of a project that I built for young people with significant physical challenges. They're students at the Boston College campus school. It's a program for students aged 3 to 21, and this edge-lit sign is controlled remotely by a light touch switch that can be attached to a student's wheelchair. This switch is attached to an enclosure that holds a CPB that acts as a remote. So a student can tap their wheelchair button, control the remote control CPB, and that sends a signal wirelessly to the receiver sign. This lets the student change the sign's color and cycle through animations. Now, we're not going to build this whole device in this lesson, but I am going to give you some sample code for sender and receiver, and this is going to allow you to send different signals. A button press that will mimic any of the 8 buttons on the Bluefruit Connect app. We'll also send a color, and we'll send text that a user types in the console on one device so that it's received and printed out on the console of the other device, a sort of one-way chat. Now, once you can do that, you can pretty much build any type of remote control that you'd like. Then on the receiver, you can respond to whatever was sent by the remote. For example, you can play a sound, run a light animation, move a motor, whatever you want. So let's learn big. So this lesson is a bit unusual in that it requires you to have two devices. I'm going to show this working on two CircuitPlayground Bluefruits. My students each have a CPB, so this is one lesson where they need to find a classmate to work with, and each of them should take turns being the sender and receiver. So first, let's look at what the code does. I've got two CPBs set up here. This is the sender, and this is the receiver. I've also given the receiver a unique name so that the sender can search for and find that device. Now on the sender, the CPB here, I've programmed the 7 capacitive touchpads to send the exact same signal that would be sent from 7 of the 8 buttons that are in the Adafruit Bluefruit app. Buttons 1 through 4, plus up, down, and left. This means that you don't need a smartphone with the Bluefruit app. You can just use a Bluefruit device running CircuitPython to act as your remote control. Now pressing a touchpad on the sender sends a button press, and when the receiver over here receives it, it will light up as long as a pad is depressed, and it will play a sound. I've debounced the touchpads on the sender so that we only send one press while a finger is held down on the pad. Raising a finger off the pad will send a signal to turn off the lights. And I've programmed this a bit differently, so instead of sending a button press, what it does instead is it sends an RGB color. When the finger is raised, I just send black, that's RGB 000. When the receiver receives this, it uses that to turn off all the lights on this CPB. Now there is an 8th button on the Bluefruit app, right, and I've programmed button A on the sender or remote control to send that button, and it also changes the color on the remote and plays a sound. Now, one other thing I've done is I've programmed the remote so that when you press button B, this uses Python's input command to request user input from the console. Now, once the user enters text and presses return, whatever they typed is sent to the receiver, which prints whatever was typed to the receiver's console. So let's get our code and see how this works. So you'll find the files needed for this project in a GitHub repo at github.com/Gallagher, that's GALLAGHER/CPB-2-CPB-over-Bluefruit, and that's all lowercase. Now, once you get to that page, you'll see a short README describing this project. Now, in this lesson, we'll use two files in the folder that you see here, sendercode.py, that'll be saved to the sender CPB using the name code.py, receivercode.py, that's going to be saved to the receiver CPB, also as code.py, and we're also going to put this folder, drum sounds, on the receiver CPB. It's got 8 sounds that the receiver will play, one for each button signal that it can receive from the sender. Now there's also information in here with replacement files if you wanted to use a potentiometer to send data to a receiver to change color, or use a potentiometer on the sender to rotate a servo attached to the receiver. We're not going to cover those two things in this lesson, but if you wanted to explore other methods for sending and receiving data, feel free to check out those files. Hopefully you find them well commented. So to get this code, just click the green code button in the upper right. A drop-down will appear, selected download.zip. My browser's configured to ask me where to save. I'm going to save mine to the desktop. If your browser doesn't ask you this, then it's probably saving it to your downloads folder, so go there to find the code. Now my browser has also unzipped the zip download. If yours hasn't, double-click that zip file so that you'll be left with a single folder with the name of the project repo on GitHub, CPB to CPB over Bluefruit, with the word main appended to the end. And we can open open that folder. Now let's install the files on the two CPBs. So plug your sender CPB into your computer. You can open up the CircuitPy volume, then delete the code.py file off this CPB and drag the sendercode.py onto the sender CPB and rename the sendercode.py file so that it's just code.py. And make sure .py isn't repeated twice. I've seen students create a file named code.py.py and wonder why it wasn't executing. You need to have only one .py. That's the extension at the end. Then you can disconnect the sender CPB and add the receiver CPB, and also delete the code.py file from this CPB. And if you're worried about not having enough space, if you have any sound folders on here, you can delete them since you won't need them on this build. Then copy the receiver code.py onto the receiver CPB. Again, change the name of that file to code.py. And copy over this folder named drum sounds. That contains the 8 sounds that'll play on the receiver. And let's test out our code. So here's my sender. Here's my receiver. This looks like it's working. So now let's look at the sender code first. So with the sender plugged into my CPB, I'm going to go into moo, and I'm going to look at the sender's code.py file. And you should see something that looks roughly like this. Now I may make some tweaks to the code from time to time to improve it, or to make some changes if things change in CircuitPython, but this should be pretty much what you're seeing now. You should see the word sender in all caps clearly showing in a comment up top. And now let's look through our code. So I put comments and marked with equal sign the code that's needed to set up Bluetooth and some functions and additional code that we'll need as well. I put all these together up top because I figured if you want to raid this code and quickly copy out the Bluetooth stuff, there it is. Now to talk through this, there are a bunch of imports in here. BLE Radio is the library that lets us work with the Bluetooth hardware on our device. Now this statement here that imports provide services advertisement is going to be able to work with Bluetooth advertisements. Advertisements are how Bluetooth devices broadcast their name and how other devices find them. Now down here we're going to look for a very specific advertised receiver name. Mine is set up as profg-r, but you'll want to change that. More on that in a minute. Then there's an import that says UART in here. UART stands for Universal Asynchronous Receiver Transmitter. Now this is the way Bluetooth exchanges data between devices. The specifics aren't really important to us at this stage. Just know that UART is how the exchange happens, and we're going to look for devices that are capable of UART transfer over Bluetooth. Now, Bluetooth also sends and receives data in what are called packets. You can consider those to be sort of like little data envelopes, and we're going to be using 3 different types of packets. The button packet mimics the button presses in the Bluefruit Connect app. The color packet allows us to send an RGB color, and the RawText packet allows us to send text. That'll be the text the user types into the console after they press button B on our sender CPB. Now below this, the receiver underscore name is the unique name that we're going to give the receiver. That's the name the receiver will advertise. So what we're saying here is I'm going to look for a device that's named profg-r. Now one thing that's super important, this name has to be 11 characters or less. If it's bigger, it won't be recognized. I've spent hours trying to figure out why my code didn't work, only to find out later that I gave it a name that exceeded the 11 character limit. Now also for my students, you're going to want to change the receiver name right here in your sender code, and you'll also use this same less than 11 character name in the receiver code.py file as well. We'll look at that in just a bit. Just make sure that it's spelled and capitalized the same way in both code.py files or the devices won't be able to find each other. My students won't want to keep profg in here because if there are a bunch of students that have devices with the same name in here, I have no idea what sort of wackiness will ensue when these devices try to work together. Next, we'll create an object so that we can work with a Bluetooth radio, and we'll initially set a flag that says if we have a connection to none since we haven't connected yet. Now this function here, sendPacket, is the function that actually sends the packets, the messages, to our receiver. It accepts the name of a connection that we'll eventually establish and a packet that we want to send. It could be a button press, a color, or raw text. Then it tries to send the packet, and if it does, the function returns true, it was sent. This extra try after the first accept tries to send the packet as text. This is what's used if we send a raw text packet. If this is successful, then we'll return true. And if that doesn't work, we failed, and we'll return false. So the try is what happens if things work out. The accept statements just catch any occurrence where this doesn't work out. We'll recognize that we couldn't send a packet properly. Then we'll make sure that we've disconnected from the device, and we'll try to reconnect again. You shouldn't need to change this code at all. It's a great reusable function. Then below this should be some setup that's familiar to you if you've been working through CircuitPython school. Here we set up 2 buttons that are built into the CPB, and these are both debounced buttons. Again, if you're new to this and you want to learn how this code works, there's a lesson on debounced buttons on the CPB in our CircuitPython school playlist. Now this next block of code sets up the touchpad so that they can act as buttons too. So there are 7 touchpads on the CPB. Pads here is an array of all of the pins or pad locations that can act as touchpads on the CPB. And we're going to create an empty touchpad array. And then we're going to loop through all of the pads that we just set up in that list. And we're going to create a touch.io touch-in device using that pad. So touch-in is a device that can act as a touch input. But we're going to do one more thing to each touchpad here. We're going to run it through this capital B button class, because that's going to make the touchpad act as a debounced button. A debounced button will only register a touch and a release. It won't repeatedly register a touch if you keep your finger on the button or on the pad. And again, how this works and why we need it was all described in our lesson on debouncing buttons. We're just debouncing the touchpads here, and they'll act exactly like debounced buttons. So after this chunk of code here runs, we have 7 elements in an array called touchpad. Each element acts as a debounced button, and we can refer to the pads individually as touchpad in brackets, whatever the index is, touchpad bracket 0 through touchpad bracket 6. Now this array here called Bluefruit underscore buttons is an array of objects that mimic the buttons in the Bluefruit Connect app. So buttons 1 through 4 and buttons up, down, left, and right. These aren't physical buttons, but by sending these button packets, the receiver receives a message that's the same message that we would send if we press the buttons in the app. And now onto the while true loop, which is the body of our code. And in this if statement here, we check to see if we're not connected. And if we're not connected, we're going to scan through all of the devices that the Bluetooth radio on this CPB can find. We're going to look for the receiver name that we set up above. This name should be the same 11 characters or less name that we set up in our receiver code.py file. If we find it, we make a connection and we break out of this loop and we stop scanning because we have a connection. Now, if we have a connection, this while loop repeats over and over again as long as we're connected, looking for us to touch or release touchpads or buttons. This for loop here looks through all of the touchpads that we've set up one at a time. Now, since each of those pads act as debounced buttons, we need to call the touchpad update on each element of the touchpad array. Remember, the .update method makes sure that we're getting the current state of the touchpad button. That checks to see has it been pressed or depressed since we last checked things. Now, if touchpad I has been pressed, if this is true, then we get the element for the Bluetooth button that we want to send. And again, each touchpad we want is going to send a button code corresponding to a button in the Bluefruit app. Those are buttons 1 through 4 or up, down, and left. Remember, we set this Bluefruit buttons array up here with different button packet codes in it. So now this if statement calls the send packet function, which sends a packet. Now this code might be a little bit rough to read, but when we look up here in send packet, this try statement here is what happens if we get a packet in, we try to send a message. If this works properly, then we skip down here. This function returns a true. We've sent our packet. Now if this first attempt to write the packet to bytes doesn't work, then we'll head down here in the accept and we'll try to send it by just writing the packet. So this command here is what we need if we send raw text, and if that works, we'll also return true. But if we haven't been able to send our packet, then we get an exception. Except means we failed what we tried to do. Then we're going to try to disconnect, and in either case, if we haven't sent the packet, we're going to send back false. So back down here in this if statement, if we sent back a true, then our packet send worked. So we can read this if statement as if not true that we were able to successfully send a packet, then we go inside the if statement indents here, we set the connection to false, and we continue. So continue skips the rest of the code below it, and it restarts the loop that we're in, which is this while loop. But since just before we called the continue statement, we set UR connection to none, then this whole while loop fails, and we restart the while true loop. So we'll head up here. So we just set our UART connection to none. We don't have a connection. So up here, we're going to repeat scanning all devices until we find the device we want to connect to again. And you can actually try this out on your own. If you send a few messages from sender or receiver, then unplug the receiver, then you'll see the sender go back to scanning until it finds the receiver again. So this is a really nice fail-safe in your code in case the connections are lost. So that's it for our touchpads. We send the appropriate button packet for the button press that we want to mimic whenever we touch on a touchpad. Now right below this, we're also going to look for a release of each touchpad. And when the finger is released from the touchpad, we're going to send a color packet this time, not a button packet simulating a button press in the Bluefruit app. Now we could send any color we want, but here we'll send 000. And we'll see later on in the code.py that's going to be on the receiver CPB, that'll be used to turn all our NeoPixel lights off. And we don't need these print statements in here, but I like to include them in my code to verify certain points in our code have been reached and they're working as expected. Now the code below this here responds to button presses on the CPB's built-in buttons. Both button A and button B have been set up as debounced buttons, so we call the update method on each of these buttons. Then if button A is pressed, we do the same thing that we did before. We're going to try to send a button packet by calling our sendPacket function. If this doesn't work, it comes back as false and we'll disconnect. Otherwise, we send the packet. And then down below here, if button A is released, we do the same thing we did up here for the touchpads. We send the color black. So we just learned to send both button packets, that's what we do when we're detecting a press, and we send color packets, that's what we're doing when we detect a release. Now this last bit, if button B is pressed, is different. We're using the input statement in here. Remember what this does in Python? It's going to prompt the user with whatever string we have in here, and whatever the user types in after that, when they press return, is put into a variable to the left of the equal sign. So we're going to put that in a variable that we call user_input. Now we need to do just a little bit more when we work with Bluetooth here. So we're going to add a carriage return and a new line after whatever the user types, because the input statement doesn't pick that up. It just picks up what's before the carriage return. So \r\n is going to include those characters in the statement we send. Then down here, we have the same call in the if statement to send_packet, but instead of sending a color packet or a button packet like we did up here, we're just going to send the user input. Up here in our sendPacket function, if we send raw text like this, the first send where we write a packet to bytes won't work, but when we try the exception down here, just writing the packet, that should work. You shouldn't have to worry about those details. If you pass this function the right kind of data, it'll just get the job done. And that's it. That's all our sender code in action. Now, the important thing to remember is if you want to send anything different, say send messages from a button press or messages from external buttons that you've set up, or even the results of something like a potentiometer selection, then you do all of this at this same indentation level up here. So below the while true loop, inside that loop where we have while UART connection and UART connection dot connected. So you'll put your same user input code in here that you would use, say, for a potentiometer. Then once you get the result that you want, you're going to package that up in a packet, maybe a color packet or a text packet, and you're going to send that to the receiver. And then in the receiver code, you're going to receive that result and you're going to respond to it by doing whatever you want to do, like change a color or move a servo motor. You can check out the additional demonstration code you downloaded from GitHub if you want to learn more. So now I'll close this code.py file and I'll unplug the CPB that has the sender or remote control code on it. Then I'll plug in that CPB that I put the receiver code on and those drum sounds. Then with my receiver board mounted, I'm going to get back into Moo and I'll click load to load up code.py on my CircuitPy volume, and let's take a look at that receiver code. So this file should clearly say receiver at the top. The comments here describe how the sender works, what type of packets are sent, how this program, the receiver, will interpret those commands and translate them into actions. So here's the Bluetooth setup code. Now our imports here are similar to the imports we put in the sender code that we just looked at, but we are importing the basic packet class here too. We didn't do that in the sender code. So do note that the code is different. Don't assume that the Bluetooth code in one is the same as the Bluetooth code in the other. It's not. Now there is some code that isn't in here because we don't need the send packet function. We're only receiving packets in the receiver. It is possible to write code that would both send and receive, but we're not doing that here. Also, make absolutely sure that you've changed the name in the advertisement.complete name to whatever you set your receiver underscore name to in your sender's code.py file. If both those strings aren't exactly the same, then the devices aren't going to find each other. And a reminder to my students who are going to be working with lots of these things in class, choose a unique name, again, less than 11 characters, so that your device isn't confused with anybody else's in class. Then the code below this is familiar to anyone who's gone through CircuitPython school. This just sets up the speaker on the CPB so it's ready to be used to play sounds. You also want to make sure that your path is properly set, so all of our sounds in this example are in a folder called drum sounds with a capital S in there, one word spelled just like this. If you rename your sounds folder, make sure that you change this line here. Then we've got the same play_sound function that we used earlier on. This just accepts a string that's the name of the file with the extension for any of the .wav files that we want to play, so this plays WAV files. If you wanted to play MP3 files, we had a lesson that covered how to do that. And below this, I've set up a list named drum_sounds, and it has the names of the 8 sounds, one for each of the button packets that are going to be sent from the sender CPB. And down here is very familiar. We set up the 10 neopixels that are built into the CPB, and we call these pixels. And under this, I just create a bunch of names for a bunch of the different colors and then combine them in a list called colors. In previous examples, we read these colors in from the Adafruit LED animations library. I just put in the direct literal for the RGB values here. And just so that you know, there are 12 colors that are listed here. We're only going to use the first 8 because we're sending the touches on the 7 touchpads on the CPB, and we're also sending a value if you press the button A. but this is just a block of code that I copy and paste whenever I need it, so there are some colors here that we're not going to be using. Then we've got an array called Bluefruit_buttons. This has 8 values representing the 8 buttons that were sent, mimicking the 8 buttons in the Bluefruit Connect app, and we have this exact same array in our sender code. And then we hit our while true loop. So the first thing that we do here is advertise the device. Now remember, our sender is looking for an advertisement with the name that we set above as the advertisement.complete_name. Now I also print out the name here just to check to make sure that we're advertising the name properly, so it's nice to have that print in the console. And this will also show up if we get disconnected and then we restart the while true loop. Then we set this was_connected flag to false since we haven't connected yet. And then this while loop here will keep cycling if we've just advertised but are not yet connected, or if we have connected. Now this seems really weird, but one of the things that this does is it ensures that we don't advertise over and over again unless we lose our connection. So while we're not connected, we're gonna keep spinning inside of this while loop until the sender connects with us. And once that happens, we jump inside here. That's the code underneath ble.connected. We set was_connected equal to true. And this also means that if we lose our connection, ble.connected is false, so we head back to the start of the while true loop, the outer loop that encloses this, and we'll advertise again so that the sender knows to reconnect. And we can only advertise once, so that's one of the reasons why we have the was_connect in here. If we tried to advertise twice in a row while we weren't connected, we'd get an error. Now this bit down here, if UART.in_waiting, checks to see if there's any new data that was sent from the sender CPB. And if so, we try to get the packet. If it doesn't work out, we get an exception. Then we must have disconnected. BLE connected is false, so that'll bring us to the top of the while true loop. Now remember, the packet might be one of 3 types: a button packet, a color packet, or a raw text packet. Now isInstance checks to see what type the value is. So isInstance packet, button packet will be true if our packet is an instance or it's of a type button packet, meaning it was an object that was created from the class button packet. And if it is, then if packet.pressed checks to see if the button was pressed down. Even though we're not checking it here, we could send events if the button was released, and that would just be packet.released. Just know that you can send button release events and respond to them too. Then we go through all of the possible Bluefruit_buttons that could have been sent. And when we find the button in Bluefruit_buttons that was sent, so that button element matches the packet.button, then we know which element in the button array was sent, which button press we're trying to mimic. We use that same index number for the button we just found to fill in our pixels with the same element in our colors array, and to play the drum sound that's appropriate for that button. So if we pressed button 2, that's the second button up here, but remember we're 0 indexed, so the index value that we get is actually 1. So we fill in the CPB's pixels with the color at index 1, that's magenta, and we play the drum sound at index 1, that's bdtech.wave. Now I'd mentioned that we're not checking to see if a button release was sent from the sender. Instead, the sender is going to send a color to the receiver whenever the button was released that's checked on the sender side. So if isInstance packet color packet means the packet object that was sent over was created with the color packet class, and we can use that to fill in the neopixels, named pixels, with packet.color, which should be 000. That's the black color that we sent over when the finger came off of a touchpad or button A on our sender. Finally, we check to see if the packet is an instance of RawText packet, that is the packet an object that was created using the RawText packet class. And if that's the case, then the user typed in a message in the sender's console in Mu, so we're going to grab that message and we're going to print it out in the receiver's Mu console. We preface this with message received : and packet text decode strip is just a lot to enter here, but it means that we're going to make sure that the text is set up in a readable format without any extra characters printed. That's it. Now, the thing to remember if adapting this code is that if you wanted to write different code to respond to any of these events, for example, you could send a raw text value that the sender might send that's a number from 0 to 180, indicating what angle a servo should be set at. Then you could set up code in here to respond to the message. So you'd convert that number, which is sent as a text, back into an integer, and then you'd set the servo to that angle. And you could do the same up here if you had any special responses for any of the buttons that you'd want to execute when the button was received. And in the color, if you wanted to add a neopixel strip, you could add code in here to light up a neopixel strip when the color comes in. And again, feel free to check out the additional files in the GitHub repo. One file is a modified sender file that works with the receiver we just saw, but you'll hook up a potentiometer to A1 on the CPB and dial a color on the receiver. And the other sender file allows you to rotate the potentiometer and send a raw text value that's a string containing a number from 0 to 180. And then the replacement receiver file will work with the servo attached to the receiver, and that servo will move when a raw text value is sent to the receiver, with a number corresponding to a servo angle between 0 and 180. So there's lots of additional content in here for you to work with and modify if you want to create any remotely controlled Bluetooth projects. But Maker, these are some pretty advanced skills. You learn how to use code to remotely control one device from another, so now use that skill to go and make something awesome.